Hello, my name is John Reagan. I'm an online Pace University student. This video is a term project for the class Emerging Broadband Technologies. In this video, I will discuss components that make up a fiber to the premise network. I will cover topics such as optical line terminal, dense wave division multiplexing, fiber at the fiber portion of the network, and the optical network unit at the customer's home or business. FTP was developed to address the demand for more bandwidth. It also allows telecom companies to compete with cable providers by providing video, analog, voice, and data. Also, cable companies can now compete with telecom companies by providing voice along with data and video. The advancements made with technologies such as wave division multiplexing has made FTP possible. Dense wave division multiplexing is a technology that puts data from different sources together on an optical fiber with each signal carried at the same time on its own separate light wavelength. This allows voice, data, and video to be transmitted over a single fiber. At the receiving end, the signal is demultiplexed and separated back to its original wavelengths into voice, data, and video. Optical line terminal has the switching capacity of 20 gigabits per second and provides ATM lease lines, high-speed digital lease lines, switch digital video, standard analog, integrated services, and digital network services. The terminal is located in the carrier's central office and is the interface point between the access system and the various service points in the network. The optical portion of FTP uses either direct fiber or shared fiber to the customer's home or business. Direct fiber is very expensive to deploy, even though it is the most desired, because each customer gets a fiber dedicated to them from the central office. However, direct fiber, due to the cost, is only used in very small service areas. Shared fiber is more commonly used. Each fiber leaves the central office is actually shared by many customers. When the fiber gets close to the customer, it then splits into individual customer-specific fibers. There are two competing optical distribution network architectures: active optical networks and passive optical networks. Active optical networks rely on some sort of electrical powered equipment to distribute the signal, such as a switch, router, or multiplexer. Each signal leaving the central office is directed only to the customer for which it is intended. Incoming signals from the customer avoid colliding at the intersection because the power equipment there provides buffering. Passive optical networks do not use electrically powered components to split the signal. Instead, the signal is distributed using beam splitters. Each splitter typically splits a fiber into 16, 32, or 64 fibers, depending on the manufacturer. A beam splitter cannot provide any switching or buffering capabilities. The resulting connection is called a point-to-multipoint link. For such a connection, the optical network terminals on the customer end must perform some special function. Once on private property, the signal typically travels the final distance to the end user's equipment using an electrical format. A device called an optical network unit converts the optical signal into an electrical signal. Optical terminals require electrical power for their operations, so some providers connect them to backup batteries in case of power outages. Optical network units use thin film filter technology to convert between optical and electrical signals. For fiber to the home and businesses, it is common for the building existing phone systems, local area networks, and cable TV systems to connect directly to the ONT. Here's an example on FTP network from start to finish. This is a rough block diagram displaying how voice and data are connected to the OLT and combined with video at the wave division multiplexer. The signals are combined and transmitted over one fiber. That signal is then split and transmitted over 32 fibers. Each of the 32 customers has an ONT to demux the signal and separate it back into video, voice, and data. For the last year, I've been a subscriber to Verizon's Fios, using fiber to the prem. I have no complaints so far. The high-speed internet is excellent. The high-definition picture on television is really great, and the phone service is pretty nice and clear. That concludes this term project. Hope you enjoyed it. Thank you.